I've spent the last decade working in DevOps, and over the years, I've had countless conversations with people trying to break into the field. Some come from traditional IT backgrounds, others from software development, and quite a few were transitioning from completely unrelated industries such as teaching, finance, and even healthcare. But in nearly every conversation, one question keeps surfacing, and that's the question of certifications. Certifications are still one of the first things people turn to when they're starting out, and it makes sense why. Certifications come with structure, they give you a syllabus, a goal, and a timeline. When everything about DevOps feels overwhelming, that kind of structure can be comforting. If you're coming from a non-traditional background where you probably didn't get formal training or don't have a computer science degree, then certifications feel like a way to prove that you belong. And I'm not going to sit here and pretend I don't understand that mindset. I've gone through those certifications myself. I've taken numerous AWS exams. I've also passed Terraform, Prometheus, GCP, and Kubernetes certifications. And beyond just writing the exams, I've written guides, shared resources, explained the tricky bits, and supported people through the preparation. So I want to be very clear from the start. I don't think certifications are useless. I don't think you're wasting your time if you're studying for one now. The truth is, when approached properly, especially the hands-on scenario-based ones, certifications can be helpful. They can introduce you to tools and concepts you did not know existed, and they can help you stay focused when you feel lost. But they cannot be the only thing you rely on. And that's where a lot of people get stuck without even realizing it. Here's what I've seen happen over and over again. People finish one certification and they don't feel job ready, so they sign up for another one, then another one, and another one. Okay, let me stop there, but I reckon you get my point. At that point, badges have been collected, LinkedIn updated, but they still don't feel like they know how to solve real problems. And that feeling sometimes stays with them for months, because deep down, they know something is missing. The issue is not that certifications are bad, it's that they can't really teach you how systems behave under stress. They can't show you what to do when something breaks in a way that wasn't covered in a course. And they certainly don't prepare you for the kind of judgment calls engineers have to make when they're staring at conflicting signals and no one else has the answer either. That's what I want to focus on in this video. Not to tell you that certifications are wrong, but to show you what comes next. I want to walk you through some real-world DevOps scenarios that closely resemble the kinds of problems DevOps engineers run into on a real job. In each scenario, I'll break down what happened, what signals were there, what steps were taken to debug, and how you can replicate something similar to practice the thinking that goes into solving these kinds of problems. And after those scenarios, we'll shift gears. We'll talk about how to build a project that ties all of these together. So sit tight, as this is going to be a fun one. And with no further delay, let's get into the first scenario. Imagine you're part of a team at a company like Instagram, and your responsibility is to make sure media uploads like images and videos flow through the system reliably. In this scenario, here's the existing architecture. Uploads are handled by backend services running in Kubernetes, and the raw media files are stored in AWS S3. Once a file lands in S3, a background worker is responsible for picking it up, processing it, performing actions like generating a thumbnail, compressing the image, or for a video, transcoding it into multiple formats. So, it's the start of a new week, you're feeling pumped, had a lovely weekend, and you get into the office at 9 a.m. Typical day, nothing unusual. You've added comments to tasks you're working on, to provide a status update to your team. You've glanced through your calendar to see what meetings you have for the day. And then, a few minutes later, a member of the product team walks to your desks and goes, "Hey, users are complaining about image uploads being stuck." Then you ask, "Can you share a bit more details?" And then they inform you that for some users, video uploads just spin indefinitely. And for another subset of users, image uploads seem to go through but never get displayed on their profile. At this point, you agree something is definitely wrong. but it's not immediately clear where to look. Then you say to the product manager, please give me a moment to look into the situation. You start debugging, you look into system metrics, you check CPU usage, memory, and observe the health of your Kubernetes pods. Everything looks fine. There are no visible spikes, no pod restarts, and no failed deploys. From a surface level monitoring perspective, the platform looks healthy. So you continue to dig deeper. You move to your Grafana dashboards where you're tracking media uploads and download metrics, and you notice that the worker is behaving quite unusual. It hasn't failed, but it's slower than normal. That doesn't seem like it will break any uploads, you think? But it's enough to warrant a closer look. You then check the logs from the worker, and now it becomes clearer. Every time the worker tries to fetch or upload a file to S3, it throws an access denied error. And you immediately go, that seems like an IAM issue. Now that you have a clear error, you pause to think about how your worker communicates with S3 in the first place. And then you remember you've not set up IRSA, which is IAM roles for service accounts, but you still use an IAM access key and secret to connect to S3 from your pod. And then you tie it all together. At this point, it's obvious your worker no longer has the right credentials to access the S3 bucket where media files are stored. Now you decide to raise this issue with your team, and then one of your teammates goes, I actually rotated the IAM keys for the application user earlier today. Rotating keys is a good security hygiene, but in this case, the updated credentials were never rolled out to the Kubernetes environment. The worker was still using the old, now expired keys stored in its secret. So although the pod was running just fine and Kubernetes showed everything as healthy, the service was effectively broken. Media uploads looked successful to users, but the background processing steps silently failed, leading to all the issues that erupted. This is the kind of problem that can be easy to miss and painful to debug, because technically nothing crashed, nothing restarted. The infrastructure was stable, but the business logic was highly degraded. And this is what often trips up newer engineers, the difference between a system being up and a system doing the right thing. There are a few important lessons here. And first is automation. If the process of rotating IAM credentials and updating them in Kubernetes had been automated, perhaps through a GitHub flow or a scheduled job tied to a secret manager, this wouldn't have required manual intervention at all. The more you automate these kind of management tasks, the fewer surprises you face in production. Second, communication. As a DevOps engineer, you're not just building systems. You're part of a team, and that team works best when everyone knows what's changing. A quick update in Slack, a ticket comment, or a simple heads up could have alerted the team that credentials had changed, saving hours of investigation and reducing or even completely eliminating the impact on user experience. Now, let's look at another scenario. You're working as part of a platform team at a fast-growing e-commerce company, and one of the services under your responsibility is the cart system, the part of the platform that stores what users add to their shopping carts while browsing. It's an essential service, as you can tell, as customers expect their carts to be reliable, even if they come back hours later to complete a purchase. In this scenario, let's assume the cart data is stored in Redis. And like many systems that use Redis, there's a time to leave or TTL value attached to each key. In this case, it's designed to expire on used carts after 24 hours. That setting is controlled through a simple environment variable which has been part of the configuration for as long as the service has existed. And most people on your team never think about it because it just works. Then, out of the blue, customer support flags a strange increase in complaints. Several users report that their carts are mysteriously empty. A few say they stepped away for a short break, and when they came back, everything they had added was gone. Others say they had items in their cart, navigated to a different page on the website, and when they returned a few minutes later, it was as if they had never shopped at all. From an infrastructure perspective, everything looks stable. The cart service application is running smoothly. Redis looks healthy, there are no unusual logs, and nothing in the monitoring dashboards that you've created indicates a performance issue. Your alerts have also not fired, your CI/CD pipelines show successful deployments, so on the surface, the platform appears to be in great shape. But obviously, you have to keep investigating and you keep digging because the user reports are too consistent to ignore. Eventually, you decide to take a closer look inside Redis itself. You query the keys associated with active carts and inspect their remaining TTLs. That's when you find the problem. Every new cart is set to expire in just 60 seconds. At first, that doesn't make sense. The TTLs have always been 24 hours, so what could have happened? You check the application code and confirm logic hasn't changed. Then you go back to the last deployment and look at the application config. That's when you notice that in a recent cleanup effort, someone removed several unused environment variables from the values file. Apparently, one of them happened to be the variable that explicitly sets the cart TTL, and without it, your application silently reverts to its internal defaults, a value that was set to just 60 seconds. As you can see, in this case, there was no failure on the application deployment or in the app logs, but the business logic had changed in a critical way, which unfortunately no one noticed until users began to complain. And if you've ever wondered why observability and configuration management matter, this is exactly why. In this scenario, there are several things that could have helped. First, application startup logic should include validation for required settings. If the TTL value is not explicitly defined, your service should either refuse to start or log a clear error. Second, observability tooling should go beyond system health and start capturing behavioral indicators. For example, tracking how many carts are created and how long they remain active could have quickly revealed the drop-off in expiration time. And finally, any change to configuration, no matter how minor it might seem, deserves scrutiny by the entire team. And as you've seen, the removal of what looks like an unused variable can alter behavior in unexpected ways. Now that you've seen these examples, you might be wondering how to bring it into your own learning. You've probably asked yourself, is there a way to tie these together into a meaningful project? Yes, there is. But before we get into that, there's an important point I want to clarify, especially for those who are newer to the field. If you're working in DevOps and want to thrive in the field, you should expect to do some programming. Now, that doesn't mean you'll be building full backend services or designing user-facing applications, but you often write scripts, build automation, and interact with APIs and configuration files. You troubleshoot bugs, debug pipelines, and sometimes inspect application logs to understand failures. You don't need to be a software engineer, but you do need to be technically fluent. And that fluency usually starts with learning a language like Python. It's readable, powerful, and widely used across infrastructure, tooling, and cloud automation. If you're still unsure where to begin, getting comfortable with Python is one of the most valuable steps you can take. Now, let's get back to tying all of these together in a project. I've got good news for you, which is you don't have to build everything from scratch. One of the best ways to simulate real-world scenarios is to use a project called Google's Online Boutique. If you haven't come across it before, Google's Online Boutique is a demo microservices application built by the Google Cloud team. It's open source and available on GitHub, so just search for Google Online Boutique GitHub and you'll find the repo. It's designed to showcase best practices in cloud native development, and it includes a full set of microservices that simulate a functioning e-commerce store. The application is made up of 11 microservices, including a front-end UI, a product catalog, a shopping cart service, a checkout service, a currency service, and more. And guess what? All of these services are containerized. They talk to each other using HTTP or gRPC, and they're built in different languages and frameworks, which makes the whole setup even more realistic. So you definitely don't need to start learning front-end development or trying to build payment logic. Instead, you can focus squarely on what matters for DevOps, like deployment, monitoring, observability, debugging, incident simulation, and system recovery. I know you might still be thinking, How do I get started? Start by deploying a subset of the application locally. You don't have to spin up all 11 services from day one. Choose 4 or 5 to begin with. Let's say the cart service, the checkout service, the product catalog, and the email service. That's more than enough to simulate real-world interactions across services and to start to practice your DevOps skills. Install a Kubernetes cluster locally using a tool like Minikube or Kind. And the repo also comes with Kubernetes manifest and Helm charts, so you can decide whether to use the raw YAMLs or go through Helm depending on where you are in your journey. If you're more comfortable with Docker Compose, there are some forks of the project that offer compose files, but I recommend leaning into Kubernetes early because that's where you'll gain the most. Once the app is running, treat it like a real system. Set up CI/CD workflows using GitHub Actions, build and push Docker images, create basic pipelines that trigger and pull requests or branch merges. You don't need to build an elaborate approval system, just keep it simple. Automate the common steps and make it consistent. Next, move into observability. Start by integrating Prometheus to collect metrics from each service. Then use Grafana to create dashboards. Track things like order volume, quest latency, cart abandonment rate, and background job success. You can even build alerts that fire when certain thresholds are crossed. The goal here is not to create a perfect monitoring system, but to practice understanding what normal looks like and how to spot when something is off. Then layer in logs. Use FluentBeat or Promptail to collect logs from the containers and send them to Loki, which integrates well with Grafana. Now you can build queries that combine metrics and logs in one place, giving you better insight into what's happening when a request fails or a service is misbehaving. After that, set up distributed tracing, which is where OpenTelemetry comes in. Instrument the services, many are already partially instrumented by the way, but connect them to a backend like Tempo. When it's working properly, you'll be able to follow a single user request as it flows through multiple services. Tracing gives you visibility that logs and metrics alone cannot provide. It shows you where time is spent, which services introduce delay, and how downstream failures propagate. It's one of the most valuable skills a DevOps engineer can build, especially when dealing with microservices. Now comes to the most important part. Start breaking the system. Change an environment variable so that one service cannot connect to its backend. Reduce the memory limit so a pod starts crashing under load. Introduce a faulty logic condition, for example in the checkout service, so that it silently fails to create orders. Push a broken Docker image and see if your pipeline catches it. Disable an alert and see what happens when a background job quietly dies. Each time something fails, treat it like a real incident. Open a GitHub issue, write down what went wrong, document the symptoms you noticed first, note which tools helped you pinpoint the problem, and record how you fixed it. Then go one step further, add a metric, add a new log, add an alert that would help catch the issue faster next time. This is what DevOps actually looks like. It's not just setting up a cluster or writing YAMLs, it's understanding how systems fail, learning how to reason through problems, and closing the loop between failure and improvement. And that's exactly why these kind of projects matters. Because when you sit in front of a hiring manager or join a new team, they're not going to care whether you've passed 10 different certifications. What they want to know is how you think, how you debug, how you handle incomplete information, how you recover from things going wrong, and most importantly, how you learn from them and design better systems as a result. If you build this project thoughtfully, you would have something more valuable than a certification. You would have real experience that you can point to, talk through, and grow from. And trust me, that changes everything. Before we wrap up, I want to say this again because it's important. I'm not against certifications. They're a part of the journey, and for many people, they offer structure when things feel chaotic, but they are not enough on their own, and they were never designed to be. Real DevOps work is about what happens after you've passed the exam. It's what you do when logs are unclear, when metrics contradict each other, and when your alert didn't fire but something still broke. It's about judgment, resilience, curiosity, and clarity under pressure. Everything I've talked about in this video today and more is why I wrote an ebook, From Beginner to DevOps Engineer. I wanted to create something that didn't just list out tools, but actually explained how to approach this work like an engineer. It walks you through how to learn effectively, how to structure projects, how to document what you've done, and how to build the kind of thinking that stands out in interview and on the job. Additionally, if you're looking for support beyond what you can get from courses and tutorials, I also offer one-on-one mentorship to give you a clear, practical guide wherever you are in your learning. I run mock interviews to help you get comfortable with the kinds of questions companies usually ask. We can also go through your resume together, restructure it to reflect your strengths, and make sure it tells the right story. Also, we can look at your career goals and talk about where to focus your energy so you're not just learning tools but actually building something that moves you forward. And if you're already working on projects, we can go deeper, reviewing your GitHub, talking through design decisions, simulating incident response, or figuring out how to communicate your work with more clarity. These sessions are personal, hands-on, and built around helping you grow in a real, meaningful way. And you can grab the link in this video's description if that's something you would like to explore. That's it for this video. Thanks for watching, and I'll see you in the next one. Cheers.